Today's main topic is word problems. So let's talk about the general technique. Generally speaking, what you need to do is identify the given quantities. I think it's helpful to state the units for your quantities so that you really know what you mean by quantities. And then identify so those are the given quantities. There's also unknown quantities. Identify those. There's at least one for sure because a question is being asked, but there's often more than one. And make variables for those, state units again. One of those variables is likely to be the final question. And then relate the quantities using equations. Now, this is the process of modeling, and I think it is the most challenging part of word problems. So, for instance, you have situations, and it just depends on the problem, but sometimes it's this: is one quantity the sum of two other quantities? And if that's the case, I'm using A, B, and C here to represent the quantities. Then you got to, take one quantity that's A in yellow, add it to another quantity that's B in blue, and that result is C, a third quantity. And of these three different colors, three different variables, two of these might be known, or only one of these might be known. So there might be known or given quantities, there might be unknown quantities, but you've got to relate the quantities. Maybe what a third quantity is the difference of two others, or a third quantity is the product of two other quantities, or something else, something that looks a little more complicated that might involve four quantities. You might have one number or quantity. You might have a number plus a number times number equals a fourth number, right? Or you might have a number plus another number times a variable equals another variable, or so you might have this kind of shape here that's got the four colors, the A, and then plus B in blue times C in red equals D in brown. I mean, you've got maybe all kinds of combinations of things that can occur, but you've got to relate the quantities in ways that make sense for the problem. And then once you've set up an equation, you would solve the equation. And then after that, you have to come up with a conclusion that goes back to the original question. You got to be sure to answer the original question and state units. This modeling step is the most challenging, especially this idea of when should you use plus and when should you use times, right? So is one quantity the sum of two other? Is one quantity the product of two other? So think about this. Buying a $2 item and then also buying a $5 item, you end up paying 2 plus $5, right? You pay for the $2 and in addition you need to pay $5. However, if you buy two $5 items, then you end up paying $10 total, 2 times 5. So I would always try to bring it back to this, right? Is it paying one thing and then paying for something else in addition, for instance? Or here, 2 times 5, well, two copies of the $5 thing. So this is usually the thing that gets people. You really want to pay some very close attention to whether you have a plus or a times, situationally speaking. So let's take a look at this example. At a fast food restaurant, value meal one costs $8.75 before tax. And then there's going to be a 6% sales tax tacked on. So how much is the total paid? Right? So in starting our answer, we notice that the final question is about how much in dollars tax must be paid, because we need to figure out how much in total needs to be paid. So we answer this sort of as a warm-up question. How much tax has to be paid in dollars? Now, how much tax has to be paid as a percent is 6%, but really as a dollar amount, it's take that 875 and multiply by 0.06. Okay, so what's the tax? Just to really clarify here, when I've asked in the past what's the tax, yeah, technically 6% or 0.06 is correct to say that's the tax, but that's the tax as a percentage or as a rate. When we need to know the tax in this question, specific to the fact that $8.75 is being paid before any tax is being paid, then the dollar amount of the tax, so in dollars, the tax is 0.06 times 8.75. So that's the amount of tax in dollars for this specific problem, even with a tax rate of 6%. Okay, so asking what's the tax alone is ambiguous. Sorry if I ever do that, but there's the rate or the dollar amount. And very often people just want to quote back the tax rate, and sometimes we need to take that rate of 0.06 and do something with it, namely multiply by the pre-tax amount of 875 to figure out how much tax is paid. But then the key thing to notice here is that we have to pay both the $8.75 or the $8.75 to the restaurant. We also need to pay 0.06 times 8.75. That's the dollar amount of the tax. We pay that to the restaurant, but the restaurant's going to forward that to the government, right? Since that's tax. We have to pay both, therefore we add, right? So the conclusion is that the total paid is $8.75 plus we pay this additional thing called tax, and that in dollar amount is 0.06 times 8.75. So here's the point. This is the model for 6% sales tax. There's the pre-tax amount, which is added to 0.06 times the pre-tax amount equals the post-tax amount. Post-tax amount being the total amount paid. And you'll notice, yeah, this is not an error. Pre-tax amount appears twice. Take a look even in this example right up here. Right before the happy face, there's 8.75 appearing in two places in that expression. Okay, so let's look at that model, right? And let's apply this model whether the given information in the problem is the pre-tax amount or the post-tax amount. That is always plug into the correct spot, right? So let's look at this other question. You arrive at a fast food restaurant where the tax rate is going to be 6%. You want to spend the entire $8.75 that you have. So what is the pre-tax amount of the meal? Like what can you afford as a pre-tax amount? So in the previous question, $8.75, let's call this 8.75. That was the pre-tax amount. Here you want to spend this $8.75. You have got exactly that in your pockets. And so in this question, 8.75 is the post-tax amount, right? So we don't know the pre-tax amount. That's up here at the top, right? That appears in two places. So let's create a variable. Since we don't know what it is, P in dollars will be the pre-tax amount. And so following this model, pre-tax amount, we don't know, okay, P plus 0.06 times, copy that, pre-tax amount, again, we don't know, that's why we have a variable, equals 8.75 in this new question, unlike the previous question, is the post-tax amount. So that's plugged in right after the equal sign right there, 8.75. Now to solve this equation, we need to solve for P, right? We're asked what's the pre-tax amount, so we need to know the numerical value of P. And so look, both terms that have P are on the left side. Let's factor out a P. So we have P times the quantity 1 plus 0.06 equals 8.75, and then divide both sides by what's in parentheses. So P equals 8.75 over 1 plus 0.06. The conclusion is the pre-tax amount of the meal is 8.75 over 1 plus $0.06. And we're done. There's no need to simplify this any further. That's a number. Yeah, I guess in some situation when you have a calculator, you just put that in there. But I think why even bother spending the time? This is actually a more natural way to really see what's going on anyway. So let's compare the last two questions, right? So both questions had 6% sales tax, so they both relied on this model equation that says pre-tax amount plus 0.06 times pre-tax amount equals post-tax amount, right? In the first question though, 8.75 was the pre-tax amount. So notice where we plugged it in, and then we didn't even create a variable for the post-tax amount because it was just kind of one side all by itself, so we didn't have to solve for anything in the equation. In the second question, 8.75 was the post-tax amount. So we plugged it in after the equal sign, and before the equal sign, pre-tax amount appears in two places, so it was just helpful to create a variable, right? So in the first question, we didn't really have to solve an equation. The thing that we needed was already isolated by itself, written once on the right side of the equation, so the final answer was just the expression that's on the left side. For the second question, this pre-tax amount appears in two places, and that's the thing we needed to eventually get numerically a number. We needed a number for, so it was super helpful to create a variable for that, right? Like, how are we going to talk about pre-tax amount plus 0.06 times pre-tax amount? Yeah, just that left side. How are we going to even talk about that when we don't know the pre-tax amount if we don't at least have a variable? So even though we don't know the number, creating a variable, which we happen to call little p, to represent that pre-tax amount was helpful. That way we could, even though we don't know the number, we could say pre-tax amount. What's that? Well, we don't know. So p, okay, p plus, then 0.06, so we copy down 0.06, and then times pre-tax amount. Well, again, we don't know the number, but at least we can refer to it. It's like having this label to name it. It was p. That was helpful, so that we set up the equation p plus 0.06 p equals 8.75. That way we have a full equation, and now we can solve for p. Okay, the correct way to solve the second, the correct way to answer the second question was to really set up an equation We did that and then solve for p. So warning, just to be careful, it is incorrect to say that the final answer is 8.75 minus 0.06 times 8.75. It's really tempting to do this because this computes 6% of something that's given or known, right? So this would be computing 6% of 8.75, but this doesn't follow the model, right? The model is that we need to compute 6% of the pre-tax amount. And this remains true whether we know the pre-tax amount or we don't. We still need to compute 6% of the pre-tax amount. And if you do 6% of 8.75, you're not computing 6% of the pre-tax amount, you're computing 6% of what's supposed to be the post-tax amount. So since we don't know the pre-tax amount, that's why we assigned a variable. That way, by writing 0.06p, notice that part that's highlighted in yellow, that really is showing that we mean 6% of the pre-tax amount, even though we don't know what number the pre-tax amount is. But we've called it p, so that way 0.06 times p represents the dollar amount of the tax.